We now move on to chapter 9, which is on kinetic theory of gases and thermodynamics. So I split into two sections. Section 1 will be on kinetic theory of gases, whereas section 2 is on thermodynamics. So let's look at section 1, kinetic theory of gases. Okay, so kinetic theory of gases, the goal of us learning kinetic theory of gases is to be able to understand the macroscopic properties of gas, those properties that we can measure for gas, and we try to understand it in terms of the atomic or molecular properties and behavior. Okay, so we know that gas, inside a gas system, there's a lot of gas particles that are moving around, and we know that we can measure the temperature, the volume, and the pressure of the gas. So those things like volume, temperature, and pressure, they are called the macroscopic properties of gas. Those properties that you can observe as a system as a whole. Okay, so we can observe from a macroscopic scale. Okay, but actually those properties such as temperature and pressure, they are very dependent on the behaviors or the properties of those gas molecules that are actually bouncing inside the gas system. So we are trying to relate between these macroscopic properties of gas to the behavior of the gas particles that actually constitutes the gas system. Okay, so usually when we study about gas system, we usually enclose the gas in a container. So what we can do, we can measure the volume of the container, which is the amount of space occupied by the gas. So because gas permeates through the whole container, so you can think of the volume of the container to be equal to the volume of the gas. Volume can be measured in various units. You can measure in terms of liter, or you can measure in terms of meter cube. But for the sake of our discussion in this chapter over here, we are going to keep it consistent by measuring it in terms of meter cube. Okay, we can also insert a thermometer inside this container in order to measure the temperature of the gas. So temperature is represented by a symbol of T, and it represents the degree of hotness or coldness of the gas. Just like what we learned in the previous chapter, if a system is hot, it has a higher temperature. If a system is cold, it has a lower temperature. So temperature, there are various temperature scale that we use. You have Kelvin, the absolute temperature scale, and you have degree Celsius, the Celsius temperature scale. Of course, you have Fahrenheit as well, but we are using the metric system, so it's either Kelvin or degree Celsius. Kelvin is the one that we will use when we are dealing with any temperature in this chapter. So if you have temperature in degree Celsius or in Fahrenheit, you must convert it into Kelvin before you proceed to do any calculation in this chapter. Okay, so that's temperature. What you can do also, you can insert a pressure gauge to measure the pressure of the gas inside the system as well. So pressure is represented by symbol P, and it's the force applied by the gas perpendicular to the surface of the container per unit area over which the force is distributed. So you know that there's a lot of gas particles inside this container. So these gas particles will be colliding with the container here. So when you're colliding onto a container, you're actually exerting a force on the wall of the container. So pressure measures the amount of perpendicular force that all the gas particles exert on the wall. Okay, so you measure the force applied by the gas perpendicular to the surface. So you are exerting a force at a certain angle, but you find the perpendicular force, the perpendicular component of force acting on the surface on the container per unit area. Force divided by area, you get pressure. So this force is uniformly distributed all around the container because the gas are moving randomly throughout the container. Okay, so you have volume, you have temperature, and you have pressure. And how do you relate them together? Okay, well, pressure, there's a lot of unit. Okay, you have Pascal, you have Newton per meter square, and you have atmosphere, and you have mmHg. There's plenty of unit for pressure, but for the sake of discussion in physics, we usually keep it consistent by measuring in terms of Pascal or Newton per meter square. Okay, so that's volume, temperature, and pressure. So how do you make sense of these properties in terms of the microscopic motion of the gas particles is what we are going to study in future videos. We are going to study what does temperature means if we study the behavior of the molecules. What does pressure means when we study the microscopic behavior of the molecules. We are going to relate them with quantities that are related to the microscopic behavior of the gas molecules. So that's for future videos. But for now, we know that volume, temperature, and pressure, if we are dealing with ideal gas, can actually be related through this equation. PV is equal to nRT. So PV is equal to nRT is an ideal gas equation, and you have another version in it for physics, which is PV is equal to NKT. So we are going to dive into these two equations in further details in the next video.